Okay, so this recording is meant to be an implementation of Resource Cloud Academy's first project, which is essentially an implementation of a very basic Jyoti architecture on AWS cloud, something very similar to what is on the diagram here. So we're going to have a web app server in running across a private subnet in an auto-scaling group, and we're going to have a multi-easy database also running across a private subnet group, and we're going to front this with both NAT gateways and load balancers, sorry, a single load balancer in this case, and of course CloudFront. So essentially the success metrics for this particular project is that the application that we will have installed on our web app server will be accessible from both the CloudFront distribution, but we will test access from the load balancer initially, and then we will test access from the CloudFront distribution. So if it's accessible, then essentially our implementation will have been successful. So to start us off, we'll go into AWS account, and I've done a bit of the basic setup for this just so to save on a bit of time. Okay, so more specifically, I have the networking bits for this particular project or setup. So just to run through it very briefly, is that we are going to be using a custom VPC. So I should have begun by mentioning we are going to run this project in the island region. So with that out of the way, we are going to use our custom VPC, which is already created. We are going to call our VPC BizConnect, and within this VPC we have a couple of subnets where we're going to be launching our resources. So we have two subnets for our load balancer. So this is where our application load balancer will be running. So we have ALB subnet 1 and ALB subnet 2. So all the subnets ones, these ones are running as you'll notice, all the subnets ones are running sorry for that. So all the subnets ones, they're running within the EU West one-way availability zone, while the subnets 2 are running within the EU West zone B essentially. So two subnets for the load balancers, two subnets for the NAT gateways, and two subnets for the web server. So this is where all the instances in outer scaling group, this is where they'll be launched. Then we have our routes table. So we'll have two route tables. We have one for the private subnets and one for the public subnets. For our public routes table, so our public routes table includes a route to the internet gateway. Yes, it includes a route to the internet gateway. And our private route table has, or rather should have, a route to the NAT gateway, right? That's fine. Then so yeah, so that's the security group. So we can also have a look at the security groups. So we have a security group for the database, for the web servers, and for the load balancer. So for the load balancer, it allows HTTP traffic from all sources. This is just to allow us to get in HTTP from the internet essentially. Then we have our web server. So for the web server, it's takes in HTTP traffic from the load balancer. Here we go. So I set this up. So for the Bastion role, I'd set that up as more of a test. I think we can just get rid of this because we don't particularly need it for this project. Awesome. So now we just have the one role allowing HTTP traffic from our load balancer security group for our web servers. Then finally our database. Let's have a look at the database security group. So this should also essentially allow Postgres traffic only from the security group of the web servers. Let me just confirm this. I'll also set up a role, a test role here. So this is what I need to delete. just clear this out and leave that. Okay, so now our database or the database security group only has a single rules that allows Postgres traffic in from the web server security group. So that's it for our security groups and our networking. Database is also up and running, so it's a very basic Postgres database running in zone 1B of Ireland. And if we just go into the database, we should be able to pick up a couple of very key details that we'll use a bit later in the project. So we can see our database endpoint right there. Then we can see some connection details such as the database name. We have a database username. We have a secure password right there. So I have that elsewhere, but it's good to note. So now let's get into the good stuff, right? So essentially what we're going to do is we are initially going to launch a test image, I mean a test instance, and we are going to install our application and all the dependencies and any other anything else that we require for this particular project. Essentially we are just going to do our setup within this instance, then we are going to bake that into an image, and then we are going to use that particular image to launch our autoscaling group. So I'm not going to use SSH for this just because I would rather just use SSM. So let's enable that, and then I should have a security group already set up for this. So this just allows it allows HTTP traffic from everywhere. And so what I'm going to add to this is I'm going to add a role just to allow me to remote into this particular instance using SSM rather than use SSH. So I think that's fine. Yes, I think we can then launch that instance and give it a few minutes to just come up. Okay, so as our instance is provisioning, I just remember that for testing purposes, we are actually going to add in the role to allow traffic from the Bastion security group, just so we are able to test if our connection is okay before we bake our image. So let me just add that back in, but I should remember to take this out once I've set up the autoscaling group. But for now, let's have that in just to make our work a bit easier. So this is still initializing, and we'll give it just a couple more minutes. Okay, let's see if we can connect. Okay, awesome, it's ready. So this should take us into System Manager. Okay, so we are in the terminal now. So we're first going to let's do some basic setup here first, right? I'll just make myself root to so that this is a bit easier. So first we're going to do an update. Then let's also do an upgrade, right? Just so if there's anything that needs to be upgraded in our system, let that be done, in case that causes some sort of an error afterwards. So the next thing I'm going to install here, right, it's a Postgres server. Let's click should be right. Outskirts. I actually should have just used my history for this. So let's have Postgres installed, and because we're going to run a Node.js application, we are also going to install an Node.js as well as npm for this. We'll need npm to get our application up and running. So at the moment the application is on GitHub, so all we are going to do is we are going to clone it into our home directory, but let's first finish installing all the dependencies that we require. So the next thing we are going to install here is Node.js. So just something to note is that this particular command, it installs a kind of an older version of Node.js. So as you can see, this actually installed Node.js version 12. I think at the moment the latest version is version 80. So if you need to work with a more later version, you will need to install the repository for that before running the Node.js, before running the install command for Node.js. But for my case, I'm okay with version 12 because my application is quite simple and should give me no problem. So I'll stick to version 12 for this, but just note that. So let's install npm 2. Okay, so that's done. Took a minute. So what we're going to do is I'm going to move into my my home directory, and just to confirm that yeah, we're in the home directory, we can just do an ls. So there is nothing here at the moment. So what I want to do is I want to clone the repository, the GitHub repository that has our application. So let me just bring that up. So this is the app that we are going to be running. So all I need is that link, then paste that in and give it time to clone. So now if I ls, I can see that my repository has been cloned right here. So what we want to do now is we want to move into this directory. So I'll cd into it, and then let's just have a look at all the files that are within this particular repository. So as you can see, there's quite a variety here, right? So what we are interested in for now is the environment file. So our application is going to use the connection details that are specified in the .env file to connect to our database. So the first thing that we need to do is to update this file with the connection details that we set up for our RDS database, and that will enable this particular application to communicate with our database essentially. So what I'm going to do is I'm just going to open that up, and we are going to do a basic do some editing here, right? So our host, the host is essentially the endpoint of our database. So I'll just pick that up and paste that in here. Oof. I always forget Control V doesn't work here. They have to do this the manual way. It's a single quotation. So our port will stay the same because that's the standard port for Postgres. So our database name, it's in the configuration details. So as you can see, I named my database MyDB. So this is what I need to add in here. So that will be my DB. Then my user, as we saw earlier, our user is Postgres, so let's also change that. And finally the password for our database, let me just get that. Okay, so I've added in the password for the database and I've saved that file. So now our connection details match what we have on our database. So what we are going to do is install. Okay, so our environment variables, our connection details are up to date, our dependencies are installed. So the next thing we need to do is let's start our application. So there we go. So first thing to note here, right, is that our application is running on port 3000. So let's first test that using the provided port. So our app is up. So we're going to do is we want to take the public IP address of our instance. If I paste that in and then give it a minute to load. So forgot to add that bit. So this is our application, right? So this is our to do app, and I can add in whatever that I want. Say I want to add Monday, and let's say I also add Tuesday and Thursday. Good. So we now have 3 records added, and what this means is that if we went into our database, if we logged into our database, I should be able to see these 3 records that we've added from our UI, and we're just going to test that, or rather just verify that in a few minutes. But the first test is complete. Our application is up and running on the designated port 3000. So a bit later in the project, we are going to set some redirection rules for this application, just so we don't have to append the port and we can be able to run this out of port 80. But for now, the first thing I want us to do is to test, or rather to verify from our database that the data that is being entered via the UI is actually being registered or added to our database. So what I'm going to do is just log into the database. So that's the command here. We have keyword, the command for logging into the database. You start with the keyword PSQL, then you have to provide some options, and the options here are essentially the connection details for this database. So this is not a hyphen. Oh, it is hyphen. You should provide the user for this database. Then the next thing I want to give is the ports. Just should be ports, which is 5432. Then the dash h should give, or should be followed. The should be followed sounds a lot better. So that should be followed by the endpoint of our database, and finally we need to give the database name, which as we saw earlier is mydb. So this will prompt us for our password. I'll add in the database password. And good, we are in our database. So if I do \l, I should be able to see all the databases that have been created within this instance. So our database of interest is of course mydb. So I'm just going to ensure I select that. Should be, yes, you're now connected to database mydb. Awesome. So let's see. /d should give us all the relations or all the tables that are within this database. So as you can see, we have to-dos, which is our application here, right? So what we want to do, what we want to see is, are there any records within these to-do tables? And actually, even more specifically, is we want to see these 3 records: Monday, Tuesday, and Thursday. So what I'm going to do, I'm just going to run a very basic select query. I should remember this from the very little database knowledge that I have. Select, so everything from to-dos. Let's hope that awesome. So as you can see, our database has these 3 records: Monday, Tuesday, Thursday, which matches what is on our UI. So this tells us that indeed our application is able to communicate to our database. And remember, this database is running on RDS, and whatever data will be entered on the UI will be updated on the database. So that's good. I think we can log out of that. So the next bit that we're going to cover is, as I mentioned earlier, so our application at the moment, we are running it's running on port 3000, and of course it's not ideal to have to append this at every turn. So what we're going to do is we are going to set some redirection rules for on our operating system, and we are going to specify that we want all traffic that is coming in through port 80 to be redirected to port 3000. So what that will do is that it will allow us to be able to access our application directly from port 80 without having to append that port number to our DNS name or the public IP address, or even yes, let's say the 2 of them. So to start off this process, right, it's, you know what, let me just clear this out so we can start kind of afresh. So to start off this process is we're going to run this command. Let me just copy it. And what this command says in very basic terms is that any traffic that is destined for port 80 should be redirected to port 3000. So for Ubuntu systems, right, IP tables is it's kind of like the firewall. It's what you use to if you want to set let's say filtering rules for the kind of traffic that you want in and out of your server. So what we are going to, or rather what we are telling our instance, or yeah, our systems here is that it's that just if there's any traffic that comes in, or any request, actually let's say request, so any requests that come into port 80, just send those to port 3000, because that is where application is running. And as I mentioned, this will allow application to respond to this request via port 80 directly. So we can confirm, just to confirm that this particular rule has been added to we're going to run this command here. And the good thing here is that you can actually get these commands quite easily online. So I think I'll just forward the link, a very good link that I found, a reference link for all this with the main documentation for this particular project, just if you want to have a look a bit later and get a bit more detail. So here is the role that we have added, right? And remember, it's a matter of just changing this port to wherever you want your traffic to be redirected. So in our case, we use 3000 because that is where our application is running. So if it had been running on another port, say on any other port, essentially, we will just have had to change this to the specific port that we want that our application was running on. So our role is in. So that's the good news. So the next thing we are going to do is we need to save this role. So something to note here is that if we were to shut down, or rather that this particular role here, while it works, it's not persistent. So for example, let me put it this way: if I were to bake this into an or create an image out of this instance as it is right now with just this command run, if I use that image to launch another, if I use that image to launch another instance, that instance would not be able to, our application would not be able to listen in on port 80, or we wouldn't be able to access our application on port 80, and that is because this command here, it's not persistent. So what we need to do is we need to make it persistent per se. And actually let's actually first test this out, right? So let's start our application and see if it's still if with that role set there, if we can be able to access it directly. So we'll just paste that in. Awesome. So now we can see that after setting that redirection role, we can be able to access our application directly from port 80. That's the good news. But as I mentioned, this role, it's not persistent. So if this instance were to go down and come up again, we wouldn't be able to access this application on port 80 anymore. So what we need to do is we need to find a way to make this persistent, and the way to do that is to add this role, or rather to save this particular role. So we are going to do that by using this command. So just paste that in. Okay. So what this command does, it's first of all, it saves the role that you've added. That is the save bit, and then it then writes that to the etc directory under iptables.roles. So let's so now that's written, the next thing, that the final step in this process is to make our IP tables persistent, and that means that these tables will be initialized at boot at every instance. So whenever this instance is booting, the traffic will be redirected automatically. So for that one, we're going to run just one final command here. We'll just paste that in. So there we go. We're going to install the persistence for our IP tables. So we'll just give that yes, sure. Okay, I'm good with that. Okay, good. And with that, we've now made our role persistent, so we should be able to now transform this, or rather convert this into an image, and whatever instances we launch from this, we should be able to access this application from port 80. So then what we're going to do next is, now I want to create an image from this instance. So remember, creating an image, or the custom AMI in this case, it will just capture the state of this particular instance as it is in this moment. So all the dependencies that you've already installed, any applications that are installed, will be captured within that image. So whatever other instance that we launch with this with the image that we create from this, it will have all this installed. So it does save you quite a lot of time. Yeah, it does save you quite a lot of time here. So let me just do that. So to create an image from an instance, we come back to the console, and under actions we should see an option for images and templates. So we're going to select create image, and then we're going to name this connect image, and then let's create that image. It's going to take a couple of minutes to to get to an available state. So I'll see you guys when it's ready. Actually, while we wait on that, there's actually a couple of other things that we can be doing. So let's configure some of the other items that we need. So we'll need a load balancer. So let's start by creating our target group. So our target type will be instances, because we want to send traffic to the instances that will be running within the autoscaling group. We are going to be using port 80 for this particular case. Our VPC, our custom VPC was BizConnect. Health check, we're going to use HTTP for that. So let's see what's next. Oh, a target group. Oh, the name. I forgot to give it a name. Let's name that Biz Connect. I think I should name it target. Should something better. Target group. Yeah, let's go with that. Let's see what's next. No, I don't want to add this instance. So what will happen is once we connect, or rather once we link our autoscaling group to the load balancer that we'll create right after this, all the instances that we launch into the autoscaling group will automatically be registered into this target group. So there's no need at this particular stage to manually register instances. So we are going to leave this section as it is, and we're just going to create our target group. We will come back here once we've done the linking, and we will verify that our instances will have been added to the target group automatically. So then let's create a load balancer. So we're going to use an application load balancer for this project. So let's create that. It's going to be, let's name it what? BizConnect ALB. Then we want our load balancer to be internet facing. Going to use a custom VPC. Then we want to run it across the two zones. I have the two subnets ready for it. So there's that, and there's LB subnet 2. Then we have a security group for this. Remember, I showed you this earlier. So essentially this security group, it will allow HTTP traffic into the load balancer from the internet. And then we want to forward to BizConnect's target group. I don't need any other listener for now, so we're just going to create our load balancer. Okay, awesome. So the next step would be, once the AMI is ready, we are then going to create our launch template and then create our autoscaling group. So let's just give that AMI a couple more minutes. So it's still pending. Okay, let's just refresh that. Oh, awesome, it's ready. So this is our image. This is what we just created, BizConnect image. So now we can move on to our launch templates. So let's create one. BizConnect templates. Just going to say that yes, I want guidance. So we are going to use our AMI because we do not want to redo all the work we've done. I think this was it, right? Yeah, this was it. Let's use T2s because this is not a very big use case. Then network, we already have an existing security group for these instances. That will be the web server security group. let me see. I want to enable DNS request for this. One last thing, so I'm going to add in a very short script here, right? Just one that will allow me to automatically, or allow us in this case to automatically, or one that's, let's say, one that will start our application, right? So this should be pretty basic. There. So what you need to remember here is that, remember that user data script, essentially they run as the root user, and you need to know that the root user for, or no, actually the home directory for the root user and the home directory for the other users will be very different. So remember, we cloned our repository and our application is running from within the home directory of our Ubuntu user. So we need to first cd into that directory where our application is before we start it. So that's that's basically it. It's a very simple script. I don't think we've missed anything else here. Yeah, I don't think we've missed anything, but let me just have one more look. Should be fine. Looks fine. Okay, let's just create that. And finally, let's create our auto-scaling group for our web servers. Okay, so create the auto-scaling group. We are going to name this BizConnect. Oof, ASG. Then our launch templates. I don't need to override any of these things. I'm okay with it. We only have a single version, so that should be fine. We're going to use our custom VPC, and then we're going to use the web subnets. So these are private subnets, remember. I'm okay with this. I'm not going to override that. Then we want to attach to a load balancer, right? And since we've already created that, so we attach it. We link our target group for our ALB. Then I don't need to enable any of this for now, so I'll just keep all that. I want this to be 2. Let's start with 2 and actually maintain it at 2. We don't need notifications. I can add a tag name, then say BizConnect. Yes, let's tag all new instances just for consistency. Let's look through here one more time just to make sure everything is good. This seems are okay. I think this is what we want. So let's create that group. Tag name. Oh, I'm not sure. Where is the space though? There is the space. I will not say that was Betty. Okay, so let's just give this a minute so you can just follow. You can trace the activity of your group from here, so we can be able to see what's actually happening with the instances, and the status should change all the way to until our instances are in service. Alternatively, we can go back to the instance console and just check from here whether our instances have been launched. So what we're going to do is we're just going to give this a couple of minutes for it to launch and for them to be initialized and to get to a running state. But just we can already see that 2 instances have already been launched and they're already being initialized, so that's good news. So let's just give this a few minutes. Okay, let's see. Oh, they're still initializing. Okay, in the meantime, we can check on a couple of other things. For example, we absolutely have to check on the health of our instances. So remember that. Awesome. So if our instances are not healthy here, you won't be able to access that application, because essentially what that would mean is that your load balancer cannot get to your application. So what that will mean, there is an error somewhere. So our instances are healthy. So this is very good news. Um, yeah. Okay. So let's test this. So we're going to go into our load balancer. If we click on that, we pick DNS name and then paste that in. So remember, the load balancer is it's going to use it's going to serve this from port 80, right? So if we can access this, that means our redirect roles actually worked and were persistent. So as you can see, we can be able to access this our application. This is the application that is running on the instances in the autoscaling group, and notice that we don't need to append a port number here in order to access this application. It's still running on port 3000 within the instances, but because we set the redirection roles, we can be able to we can be able to access this from port 80. So this is good news. Awesome. So this still initialize. Okay, they're good to go. So that's good. So let's do the final step, and the final step is now to set up our CloudFront. We want to see if we can now access this application from CloudFront. Remember, CloudFront, it's a lot more secure as compared to the load balancer. So while it's absolutely possible for you to leave this at this particular point, just use the load balancer DNS name to access your application. It's not the most secure way to do this. So CloudFront has far more superior features, security features, as compared to the load balancer, and this is why it's recommended to actually set this up, to have your load balancer fronted by CloudFront and have all the traffic actually coming in through CloudFront. So from CloudFront, then you can set things such as WAF roles. You can enable something like AWS Shield and a whole lot of other security mechanisms for your applications. So we're just going to set up a basic distribution for our load balancer. So I'll just need the DNS name there. So we want to create a new distribution, and first thing is to paste in the DNS name of the load balancer. So we are using HTTP, so I'll leave that as HTTP only. I don't want to specify a path. Let me just rename this to BizConnect LB. Then leave all these as defaults. Let me just confirm if there's anything I need to change here. For caching policy, I'm just going to disable that and make that all viewer. Then let's see, I'll use North America and Europe. It is a test, but remember that choice will highly depend on where exactly your users are located and where you want to optimize performance. So we can create a distribution. Now this one also takes quite a while to deploy, so we're just going to give it a bit of time to complete. Okay, our distribution is up and running. So let's test this, fingers crossed. So we take our distribution name and paste that in, and voila, here is our application. So obviously there's a lot more fine-tuning to be done here, but essentially the goal of this project was to present the most basic way, or just more of a foundational way to just get this up and running before we get to fine-tuning the details. So I certainly hope this video has been informative, or will be informative, to everyone who watches this, and specifically for the to our members who have been taking this project with us. So in case of any questions, please feel free to reach out, but otherwise I'm out. Thank you.